All right, let's do the chain rule. Thus far, we've done the product rule, we have done the quotient rule, and now we're getting closer to where we can do lots and lots and lots of different derivatives and differentiations. Thus, the chain rule. So let's look at this thing. All right, chain rule says if y equals f of u is differentiable function of u, and u can equal g of x, meaning it could be a function by itself, and it is differentiable function of x, then y equals f of g of x. And remember that this was simply called, back in the day, a function within a function, which was composite. It was called a composite function. So it's saying if this is differentiable, we can use the chain rule. And this is actually a fairly difficult way of writing it, or at least maybe understanding. It's easy to write it. What does it say? It says the derivative of y in terms of x will equal the derivative of y in terms of u times the derivative of u in terms of x. Easy way to write it, much harder to think about it. Let's think about this version right here. So it's just saying if I have a composite function, a function inside a function, it's going to equal the chain rule. Now look what this is basically, all this is saying. It's saying I'm going to take the derivative of f. That's the derivative of the outside. I'm going to leave the inside alone. So whatever this is left alone. And then I must multiply, in the end, the derivative of the inside. So f prime of g of x times g prime. Now I'm going to give you an easier way to see this using u substitution. So let's get after it. All right. It's right here. So instead of writing g of x, I'm going to write u, because all this says is I'm going to leave this alone, and then in the end, I must multiply by its derivative. So I'm going to say I'm going to call it u, and in the end, I'm going to call it times u prime. Just an easier way to write this. And let's look at an example and then kind of scaffold over and over and over again how we're going to do this. Now, let's look at this problem. This is a quantity to the 9th power. You think about having to expand this 9 times. You would kill a small forest if you tried to do that by hand. So the chain rule is wonderful. But in order to do it, we want to set this up. So I'm going to write some stuff over here over and over again. And I'm going to be thinking in terms of u. So let's write that. And, y is f of x. I'm going to call it f of u, because I'm going to call this u right there. To get inside this thing and say, I'm not going to deal with x squared plus 2x minus 3 to the 9th power. I'm going to deal with u to the 9th power. So I'm going to write it right there. And then next to that, I'm going to define what I called u. That's important. You'll see this in a minute, why we do this. Okay, so now I'm going to take this information right here, and I'm just going to bring it down. And at this point, I'm going to use the chain rule. So this is what it says. I must, right here, I must take its derivative. And then at the end, I'm going to apply times u prime. So let's look and see, well, what is the derivative of u to the 9th? Think about the derivative of x to the 9th. We would take this 9 and multiply it down. We would subtract 1 away. So I'm going to write it here. So f prime of u equals 9u to the 8th, which is the derivative of that, times what this was saying. Apply the chain rule, times u prime. So what we have right now is we have a formula for the answer. Now notice we know what u equals. I can grab it and throw it in. What I don't know is u prime. So what we're going to do is, the reason I wrote this is so underneath it, I can take its derivative. Now think about, well, what is the derivative of u? It's u prime. What's the derivative of that? 2x plus 2. So now I can take this u, which is right here, and I can throw it in right there. And I can take this u prime, and I can throw it in right there. And underneath, I can write this, what we call in terms of x. Right now, it's in terms of u. I want to put it back in terms of x. So instead of u to the 8th, I have x squared plus 2x minus 3 to the 8th, because that was u, and u prime was 2x plus 2. So there's the derivative of all of that. Now, the only thing left to do is ask ourselves, is there anything that needs to be simplified? Meaning, I'm looking for negative exponents that may need to be moved. I'm looking for factors that might need to be distributed, et cetera, et cetera. So I'm looking at this, and the only thing really that we could do is we could multiply this 9 into this. I'm not going to do that because I'm being a little lazy right now, but that is what we could do. Right now, I'm just going to circle it, smile, and move on. Okay, so we can get this sequentialness under our belt. All right, so let's look at this. Same thing. I'm looking at this problem and I'm saying, well, there's no way I'm going to expand a quantity to the 11th power. I do support the timber industry, but my goodness, that would be a little ridiculous. So let's think about this rule. In order to use it, let's think about U substitution. So let's rewrite something right here. It says, well, if I call this U, 2x to the 4th minus 5x plus 1, I now have U to the 11th. So I'm thinking about this concept right there. And I'm just next to it defining what I called U, because again, in the end, I will be taking its derivative right here. So let's move this down. So I have f of u. So it was in terms of x, now it's in terms of u. So f of u equals u to the 11th. And this rule is what we're going to use right there. It says let's take its derivative times u prime. So let's take its derivative, bring the 11 down, take 1 away, times u prime. So I get 11u to the 10th times u prime. Now again, what is this? This is the formula for the answer, which means I can take the u and put it where it's supposed to go, but I still don't know that. So let's go get it. Derivative of u is u prime, and the derivative of this is 8x to the 3rd minus 5. So now we can take the u and put it where it goes. We can take the u prime and put it where it goes, and we can write the answer underneath in terms of x. So there it is, 11u times 2x to the 4th minus 5x plus 1 to the 10th power times u prime, which was 8x cubed minus 5. And again, the only thing I could do here is I could distribute this 11 into this quantity, but I didn't. I actually like to keep things in factored form most of the time, just in case we're looking for things that cancel, and that's an acceptable answer. So we're going to circle that, move on. And I just kind of want to, hopefully you start to see, some of you will get very, very good at this by recognizing, hey, I got a chain rule problem. And then look, I'm going to show you, maybe we can go from here to here by just recognizing, I know this 11 is going to go down front. Notice it lives right there. I'm going to leave this alone, which is what that says, right? Take the derivative and leave u where it's supposed to go. Take the derivative, bring the 11 down, leave this alone, take 1 away. Notice that's 11 u to the 10th. And then what am I supposed to do? I'm supposed to multiply by the inside. Well, there it is. Okay, let's think about this. A little bit more complicated because I got a negative exponent. But again, let's scaffold this and say, you know what? I'm not going to turn this thing into anything other than a u substitution because I want to use that. Let's think about what we're going to do. I'm going to call this u. So we have f of u. F of u is now equal to u to the negative 8 because I'm calling that u. So there's my u to the negative 8 right there. And again, I'm just defining what I'm calling u because I'm going to need a u prime in the end. So let's bring this down. And let's follow the chain rule, requiring us to take its derivative times u prime. So let's take that derivative, bring the negative 8 down, subtract 1, and we get negative 8u to the negative 9 times u prime. There's our chain rule. And now, again, I have a u. It was here, but I still don't have that. And this is why I'm writing it here, so I can bring it down and find my u prime. Derivative of u is u prime. The derivative here is negative 35x to the 4th minus 6x. And now I can take this u and put it here. I can take this u prime and put it here and write it in terms of x underneath. Okay, now let's look at this because it's the first time I'm actually thinking about, well, I have some simplification I need to do. So let's think about that. And before I do it, I just want to point out what's going on here. I have a negative 9 exponent, this quantity to the negative 9. So this quantity is really to the 9th power, but this negative just indicates it's currently written in the wrong spot. So I know this whole quantity right here is going to be moved into a denominator position. It's going to be moved down. So I want to be thinking, well, I'm going to have a fraction over here. What's going to live on top? Well, everything that has a positive exponent is going to live on top. So this -8 right here is going to stay on top, and this quantity is going to stay on top, but this is going to go down. So let's look at and see what that looks like. Notice this -8 was to the first power, gets to stay on top. This quantity was to the first power, it gets to stay on top. This was being moved, so now it lives down here. Remove the negative. Again, the only thing left to do would be distribute this -8, which I probably should have done, but I'm being a little lazy. So I apologize. All right, let's look at another example, and let's turn this into a radical. Make our life a little bit more interesting. Same thing I'm going to be doing here. I'm going to be thinking about what could I call u, and write this in terms of f of u. So think about making this a u. I would have the cube root of u, which is u to the 1/3. And again, I'm calling my u over here because I know I'm going to be taking its derivative right there. So let's bring this down. Okay, now this is when we get to use the chain rule, which is right here. Let's take its derivative times u prime. So that 1/3 is going to be multiplied down. I get to subtract 1, which is subtracting 3/3, and end it with u prime, which is right there. Again, this is the formula for the answer. I have a place I can throw in my u. Let's go get u prime. Derivative of 7x squared is 14x, and now I can throw that in. So let's start off by thinking, well, the u gets to live here. The u prime gets to live here. And now I can write this in terms of x. Only thing left to do is simplify. And before I do that, I'm looking and I'm thinking in this problem, what gets to live on top? What gets to live on the bottom? Because this negative exponent right here is indicating this quantity is going to be moved down, which creates a fraction. And we already had a fraction. So let's write it and see if we can point out how I did this. So this 1 gets to live on top, and this 14x gets to live on top. That has an exponent of 1, and that had an exponent of 1. So 1 times 14x was 14x. Notice that's the only two things in this problem that had positive exponents on top. This 3 was already on the bottom. It gets to stay on the bottom. And this quantity had a negative exponent, so I'm moving that down. And the only thing I did here was I rewrote it in radical form, which was the cube root squared. The cube root squared. So there's the answer. There's the derivative of the cube root of 7x squared plus 1. All right, last example. Now I'm going to talk about this because what I've seen in the past, which does work, by the way, it just makes things a little bit more complicated, as I see students get comfortable and they start jumping in and they'll just make everything that's inside u. Well, I'm not going to make this whole thing u, and I'll show you why in a minute. I'm going to go as deep as I can and just make this u. So let's see what that would give me. So let's look at that. This would technically be the 7th root of u squared. Well, there's your root and there's your exponent. So I have u to the 2/7. And then I just went over and said, all right, I defined my u because I know I'll eventually need its derivative. So I'll go down and get it in a minute. So let's take this and bring it down. And now we can follow the chain rule. Let's take its derivative and end it with u prime. So let's take this derivative, bring the 2/7 down. Let's subtract 1, which is minus 7/7, and end it with u prime. And you should get that. 2/7 u to the negative 5/7. Again, we need this, which is why I did it here. So let's go get that. Derivative of u is u prime, and the derivative of 5x to the 3rd plus 4x is 15x squared plus 4. Oh, that's not supposed to be an x. Let's forget I did that. That's supposed to be a 4. Let's hope I didn't continue to screw that up. Again, we can throw in our u. We can throw in our u prime. And I did. That x is not a part of it at all. Let's pretend that is not there. And I will not post this for the world to see, so not everybody on the planet gets to laugh at me. Let's pretend this x is gone and this x is gone. But let's look and see. We took the u and put it here. We took the u prime and put it here. Again, forgetting that x is there because it's not. And the only thing left to do is simplify this bad boy and say, well, I got a negative exponent that I know is going to be moved. That's going to live on bottom. The 2's on top. This quantity's on top, and that 7 is on the bottom. So let's bring it over here and point it out. Let's take the 2 positive exponent, this quantity at a positive exponent, they get to stay on top. The 7 was already on the bottom. It gets to stay on the bottom, and this negative exponent came down, and I just rewrote it as a radical. Again, it is a 7th root to the 5th power. 7th root to the 5th power. And this bad x it's a bad x, does not live there. So I apologize. Bad x, bad x, bad x. Get rid of it. All right. There's the chain rule, and I almost made it through this without an error. But since this is the 3rd time I've tried this video, I am not redoing it because of that silly little critter. I'm just assuming you all have ears and you can delete that bad boy from your memory. Have a fabulous day.